All right, first we're going to look at the recursive implementation of binary search, and we'll look at iterative implementation next. So let's add a new method here, public integer binary search. Now here I'm going to add rec, as in short for recursive, to distinguish from the iterative implementation. But this is purely for demonstration, for training. Don't do this in the real world, because the name of your methods or your classes should never reflect how they're implemented. Whether a method uses recursion or iteration is an implementation detail. We don't want to expose it outside of a class. We don't want the clients of our classes to know how they are implemented. Because if tomorrow we decide to use iteration in a method that is initially implemented using recursion, we have to rename that method. And that means we have to go update anywhere where we have a reference to that method name, okay? So binary search rec, we give it 2 parameters, just like before, an array and the target item. Now here first we need to calculate the index of the middle item. And to do that, we need the index of left and right items. So we need to add 2 more parameters to this method. Left and right. Initially we pass 0 for the left and array.length -1 for the right, okay? Then here we calculate the index of the middle item, that is left plus right divided by 2. Now we check to see if the item at the middle index equals this target value. So if array of middle equals target, we're going to return middle as the index of this item. Otherwise, we have to check to see if this item is in the left or in the right partition. So if this target value is smaller than array of middle, that means it's in the left partition. So here we should recursively call this method and return the result. So we return binary search rec. We give it our array, the target item, the same left value. For the right value, we're going to use middle -1. We know that our item is not at the middle index, so we pass the index of the previous item, that is middle -1, okay? Otherwise, if we get to this point, that means this target item is in the right partition. So here we return binary search rec. We pass our array, our target value. For the left, we're going to use middle +1, and for the right, we're going to use the same value as before. Now, one last step. Here we have used recursion. You know that whenever you have a recursive method, you should have a base condition. Without that base condition, recursion will go forever until our program crashes. So right at the beginning, we want to write our base condition. What is our base condition? That is when this right index becomes smaller than the left index. That means our partition or segment is empty. Because if our partition has a single element, left and right are going to be equal. So if it has 0 elements, that means right is less than left. So if right is less than left, then we're going to return -1, which means we could not find the target item, okay? Now, I'm not quite happy with these 4 parameters that we have in this method. When calling the binary search method, I don't want to pass 4 arguments. That's a bit ugly. So I would rather declare another method here, public integer binary search rec. We give it 2 parameters just like before. And here we call this method with 4 arguments. So we return binary search rec. We give it our array, the target value. We pass 0 for the left index and array.length -1 as the index of the right item, okay? Now, the last step is to make this private so we can see it from the outside. That's better. So let's test our implementation. Back in the main class, first we need to sort these numbers because binary search only works on sorted lists. So 1, 3, 5, 6, and 7. Here we call our binary search method, and let's say we're looking for 70. We get -1, beautiful. What if we search for 7? That is 4, the index of the last item. What if we search for 1? We get 0, beautiful. So our recursive implementation is working. Next, I'm going to show you the iterative implementation.